Problem number 1, 4n plus 7 plus 6n equals 32. First thing I can do here is combine like terms. 4n plus 6n is 10n plus 7 equals 32. Subtracting 7 from both sides, 10n equals 25. Dividing both sides by 10, I get n equals, in this case, I will write it as 5 halves. 2.5 would be given also as a correct answer. Problem number 2, 5 times the quantity 3 minus d equals 2d plus 1. I need to take care of the parentheses first. So 5 times 3 is 15. 5 times a negative d is a negative 5d. And that equals 2d plus 1. Because I have a variable on both sides of the equation, I need to get rid of it on one side. I choose to add 5d to both sides. That gets rid of the minus 5d here. Leaves me with 15. 2d and 5d is 7d plus 1. Subtracting 1 from both sides, 14 equals 7d. Dividing both sides by 7, d equals 2. Problem number 3, 8 times the quantity h minus 1 equals 6h plus 4 plus 2h. On the left-hand side, I'm going to distribute. That should give me 8h minus 8 equaling. On the right side, I'm going to combine like terms. 6h's plus 2h's is 8h's plus 4. I now see that I have a variable on both sides of the equation, so I will subtract 8h from both sides to get rid of it. It gets rid of it on both sides, leaving me with negative 8 on the left side and 4 on the right side. When the variable disappears and I get a statement that could never be true, this is never true, I would say there is no solution to that equation. Number 4 is 43 equals 8y minus 11. 2 steps to solve it. Add 11 to both sides first. 54 is equal to 8y. Dividing both sides by 8. Y equals 54 over 8, I believe will reduce to 27 over 4, which I think is 6.75 as a decimal. Is that correct? Problem number 5, 8 over k equaling negative 12 over 30. I've chosen to write the negative sign with the numerator. You can put it either with the numerator or the denominator. Cross multiplying. Negative 12 times k, negative 12k. 8 times 30, 240. Dividing both sides by negative 12, k equals negative 20. Problem number 6, we have 3 over 5 equaling y plus 1 over 9. Because the y plus 1 is a fancy part of the fraction, as we've called it, I'm going to put it in parentheses and then cross multiply to solve. I will have 5 times the y add 1, so that's 5 times y plus 1, equaling 3 times 9, which is 27. Distributing, I will get 5y plus 5 equals 27, and now we have 2 steps remaining to solve the problem. Subtracting 5 from both sides, 5y equals 22. Dividing both sides by 5, y equals 22 fifths. As a decimal, 4.4. Number 7, you're riding your bicycle to prepare for a race. If it takes 12 minutes to go 2.5 miles, the question is, how long will it take you to go 7 miles? So we're trying to find time, how long it'll take you to go 7 miles. I can set two equal fractions up, cross multiply. 2.5 times x is going to equal 7 times 12, which is 84. Dividing both sides by 2.5 equals 84 divided by 2.5. Someone? 33.6 minutes. Problem number 8, we're dealing with the two triangles that have been declared similar. And similar means that the sides are proportional. Because the missing side y matches up with the 5 on the big triangle, I'm going to write 5 over y. So starting with the big triangle and going to the small one. And I need to set that equal to another pair of sides that I know, and I will use that relationship as 8 over 5. So both fractions have been written going from the bigger triangle to the small one. Cross multiply then, product of the means equals product of the extremes. 8y equals 5 times 5, which is 25. Dividing both sides by 8, y equals 25 eighths, or 3.125. Problem number 9, same situation as 8. We have two similar figures. I will set two equal fractions up that match corresponding sides. Going from the big triangle to the small one. 4 matches up with 3. 6 matches up with m. Product of the means equals product of the extremes. 4m equaling 3 times 6, which is 18. Dividing both sides by 4, m equals 9 halves, or 4.5. In our last problem, number 10, we're talking about a similarity situation. And what do we mean by similarity situation is if a person, in this case a 3.5-foot child, casts the shadow, and a telephone pole also casts the shadow, the two of them together with the angle of the sun form similar triangles. So we can use two equal fractions between these two similar triangles that we get in this drawing to figure out how tall the telephone pole is. We do have one issue in this problem, in that all of the measurements are in feet except for the length of the child's shadow, which they said was 60 inches. I know that there are 12 inches in 1 foot, so that tells me that the shadow of the child is 5 feet. So now I'm going to set up two equal fractions. The child is 3.5 feet. The telephone pole is h. The shadow of the child is 5. The shadow of the pole is 50. I now have two equal fractions. Cross multiply. 5 times h is 5h. 3.5 times 50, is that 175? 175. Dividing both sides by 5. The height of the telephone pole does come out to be 35